When you are transforming equations, you are solving for a particular variable in an equation that contains a bunch of other variables. This is sometimes called literal equations. When you are transforming equations, you're using everything that you already know about solving using inverse operations, and you're just doing so in the context of an equation that does not have numbers, and therefore your solution is not a number. When we're solving, we want to really pay close attention to what variable we're solving for, since there are so many variables in the equation. And so we suggest that you highlight the variable you're solving for. In my first example, I am solving for I, so I'm going to highlight I. Now I want to trace through what's happening to my variable using order of operations so that I can isolate my variable in reverse order of operations using inverse operations. So inverse operations in reverse order of operations. In my equation, P equals I times G, I'm thinking about what's happening to I in my equation. Well, only one thing's happening to I. I'm multiplying I by G. So P equals I times G. Therefore, to isolate I, to get I by itself on one side of the equal sign, I just have to undo that one single operation. My one single inverse operation is to divide by G. I can either show that with my division bar or with a division symbol. I'm dividing both sides of my equation by G. P divided by G is just P divided by G. This is where this is weird. If these were numbers like 6 divided by 3, I would write 2 here, but I can't divide P by G. I don't know what P divided by G is, so I just write P divided by G on the left-hand side. On the right-hand side, I have I times G divided by G. I times G divided by G is just I. So I have done what I set out to do. I've isolated I, and this is my solution. P divided by G equals I. That was a one-step equation, and actually all of the examples on this notes page are one-step equations. They look really complicated, but just one operation is being performed to the variable, and so there's only one inverse operation. Let's look at this second example. 2 times P plus I, I'm solving for I, equals G. So this one looks more complicated, but like I said, this is a one-step equation. The only thing that's happening to I in my equation is I'm adding 2P. I'm adding 2P, so to get I by itself, my only inverse operation is to subtract 2P. Subtract 2P, subtract 2P. I am done after I write that I equals G minus 2P. Again, these aren't numbers. This doesn't say something like 10 minus 2 times 3. I can't actually compute this. It stays just as is G minus 2 times P. Final one-step equation example. I'm solving for P. There's only one thing happening to P in this equation, and that is that I am dividing P by 2. That means my single inverse operation is to multiply by 2. I'm going to undo P divided by 2 by multiplying by 2 on both the left-hand and the right-hand side, so that P divided by 2 times 2 is just P. This one is a little bit different because there is a number, and I'm multiplying by a number. So this is a case where I can perform one computation. I can multiply 3 times 2. I know what 3 times 2 is. 3 times 2 is 6. What I don't know is what 6 times I times G is. So I just keep this as 6, 3 times 2, times I times G. P equals 6, I, G. I know this looks really weird, and this is a skill that takes students a varying amount of time to get, but I promise it will click for all of you. Keep trying and you'll get it. It just looks really weird to start with.